So today I'm going to be talking about how you can stop deploying at 6 a.m. and get a good night's sleep. It's a talk that I'm kind of surprised that they put on the first thing. You know, we like to sleep and you had to wake up early to get here. So I would say thanks for coming out today, and it's good to see everybody's face. I know it's been a little tough over COVID, and it's great that we're finally getting back in person and coming to these kinds of events. My name is Matt Bowlin. I'm a principal software developer at Insight. I've been developing software for 20 years now. I've been with .NET the whole time it's been around. I'm also an adjunct professor at Columbus State. I teach a class on SQL. It's kind of basic, but it has helped me out a lot on conveying information and figuring out how to teach people, and every time we run this class, I get a little bit better at it. So we've all been blessed as programmers, and I encourage you to give back as much as you can, and that's my way of kind of giving back. I'm a husband. I have 2 boys and a dog. Over COVID, everyone would get a little stir crazy. My kids literally climbed the wall. They figured out how to shimmy up the trim around doors and whatnot. So I said, you know, we need to get out of the house. We started taking little adventures around Ohio, and I became a COVID hiker. That picture there is from Lake Hope, a great little lake down in southern Ohio. You're around mountains. Well, they're probably technically hills, but there's lots of places throughout Ohio. I encourage you to get out. I thought that was kind of a neat thing that I did when I couldn't go out and see people. I've been to every stir trek. I can still remember the first one. The thing I remember the most about it was at lunch, a VW van pulled up, packed floor to ceiling with mellow mushroom pizzas. It was fantastic. We won't have pizza today, but we'll still have a good lunch. So we've all been to this 6 a.m. deploy. Your operations and your developers all get on the line, and someone copies out some code, and everyone feverishly tries to test, make sure everything works. We've got to do it at 6 a.m. or earlier because we actually take the site down for our customers. And you know, that could cause a problem if you have a big site with lots of traffic or whatnot. The important thing is that, you know, we're disabling the site. So there's ways around that I'm going to talk about now. And I generally don't like going to this 80s party line in the middle of the morning. It leads to some other problems. The tired developer makes more syntax mistakes. They are less likely to actually meet the requirements of the software you're creating. We deal with some hard problems in software development, and it's a good idea to get a good rest. And if you do too many of these deployments, it leads to burnout and decreases your work-life balance. You know, the more deployments you go to in a week, it can really tax yourself. The other reason we want to stop deploying at 6 a.m. is this whole DevOps movement, where we aim to shorten the development life cycle and provide continuous high-quality software. So we first start out with planning, and then we move to coding and building, and then testing. And eventually we move on. Well, usually there is like a gap in between the testing and the releasing. That could be days, weeks, months. But eventually we release our software, we deploy it, operate it, monitor it. And the most important thing that's not on here is we learn. We learn how the users use our software. We learn what they like, what they don't like, and we learn if they have any bugs that we didn't anticipate. So the whole aim of DevOps is to shorten this cycle. So we have, you know, our planning, our development, our testing, and then we have this whole big red line where we're just waiting on our code. The company's already paid for it, and they're not getting their value. The customers aren't experiencing the new feature, getting the value out of it. But with some of the techniques I'll talk about today, we're going to get our code deployed without this whole ugly red bar that sucks up a bunch of time. And it also decreases the lead time to value, if you've ever heard of that metric. It's how long it takes from the software to be thought up to out to production. In DevOps, there are 4 key metrics that we use to measure how our software is, our DevOps performance. We have our deployment frequency, lead time for change, and time to restore service, and our change failure rate. With our deployment frequency, we could be deploying on a low performer, we could be deploying fewer than every 6 months. More typically is a agile team who's deploying between once in a week. But the high performers, the elite performers, are deploying multiple times a day. The other metric, well, one of the other metrics we look at is lead time to change. This could be more than 6 months for a low performer, between one day and a week for a high performer, and less than an hour for an elite performer. The other key thing is their change failure rate. The more times we deploy, the lower our failure rate is going to be. And that is how often you have to put out a build and something doesn't work and you pull it back. So let's take a look at what some of these elite DevOps performers look like. So Twitter deploys 3 times a week. Facebook deploys once a day. I think they're actually up to 2 a day now. Google deploys 5,500 times a day. Amazon deploys 23,000 times a day. That's crazy to think about. That's almost 1 deploy every minute. Now, Amazon's a huge company. That includes AWS, and they have their systems all structured in microservices, so they're not deploying their main site 23,000 times a day, but that is a lot of deploys. And they do all that without putting a maintenance page up. If Amazon put up a maintenance page, we would never see their site. So how is this done? It is not done by copying files out to production. Files are copied out someplace else, and then everything is warmed up, tested, and when we are ready to release it to our customers, we actually flip a switch and the proxy will point the code from one site to another. And yes, I think that is Scarlet Witch. All right, so there's 3 methods of deployments that we're going to talk about today. We're going to talk about blue-green deployments, Canary deployments, and API versioning. And I'm going to give you a quick example of each one of these using Azure. First up, we got our blue-green deploy. And the way this works is incoming traffic is routed to a proxy, and the proxy is routed to a website. Then we introduce our new code somewhere off to the side. And we test it, look at it, make sure it looks good, and eventually we direct our traffic to the new production. And then we repeat that cycle again by bringing up another site and pointing that proxy to the new site. There are some things that your application will have to do in order to make use of these proxies and blue-green switching. If it's hosted in the cloud, it's going to be way easier to accomplish it. The other thing is it needs to be stateless. So we can't store our state in memory. If we have any sort of application variables, we got to host them either on a file system that's somewhere accessible to everybody or in a database. Another key thing is you want to have some monitoring on there so you can make sure that you are not disturbing your users as you're deploying. And we're going to do a health check to make sure everything looks good too. Then we can swap around with that. I'll do some examples of that. In Azure, we use these what's called deployment slots. They're different versions of the website with a separate URL and they are free with a standard or premium app service plan. Only one of these slots is marked as production. It has all the bells and whistles, the load balancing, the different scale out functions. So the typical use of this is to have a staging slot and a production slot. But slots have different URLs. They can be tested independently, and they can also have different configurations. So they could point to different databases, different downstream systems, whatever you want. You can set up your staging site to use that. Or you could also point it to your actual production database if that's your intention. So when the code is ready, we're going to do what's called a swap. During a swap, the config values are exchanged from the destination slot to the production slot. Then the load balancer switches the code. It also can involve scaling the site up to match production. So if you're hosted with 3 nodes in production, then you're going to have 3 nodes initially right when it rolls out to the customer. The URLs swap, but the code is always in the same, well, the code swaps, but the URLs are always the same. So you'll have your production, it'll always have the same URL. You don't need to worry about moving anything back after you do these swaps. But if you have a problem, you can roll back your code, and it is still instantaneous, well, not instantaneous, but it's instantaneous to the users. It still goes through all these same steps and pushes it out. There's 3 different types of swaps we can do out in Azure. So we have our normal swap where we click a button and it moves the proxy over and our code's out to our users. There's also a swap with preview. So in this step, it's a 2-part swap. All of the settings get applied, and then you can test it all out, and you can do all any sort of testing you'd want to do via people or via automation. Then we hit complete, and the code is moved out to production, and it's in a warm state. There's also something called auto swap, where we can swap out, we can just copy the files out to a server, and when everything becomes healthy and warmed up, it'll actually deploy it. A key thing about swapping your code is you have to watch out and make sure that your site is actually warmed up. By default, it's going to be in a cold state, slow and unresponsive. I know a lot of applications take a while to warm up, so this is something that becomes a huge concern when you're doing blue-green deployments. If you want to, you could manually warm it up by using the swap with preview that I just talked about, but I would suggest going with a more automated fashion. We can use a health checks to make sure that our system is healthy and warmed up. A health check, really there's only, once we do the code, there's just one setting we need to include in Azure. It's this website swap warm-up ping path. And once we have that, the site will make sure that it warms up, and if it's not healthy, it won't even deploy. So it's kind of a good sanity check to put on your deployments too. Here's an example of what a health check looks like. It extends from iHealthCheck, and it implements this function check health async, and we're going to return this health check result, which can be healthy or it can be failure. There's a third status in there, but that's probably a subject for another talk. So let's take a look at what the deployments look like. So here I'm out in Azure, and I have a site. Unsurprisingly, it says blue, and I have my deployment slots. Just to walk you through the process for the first time, I'm going to create a slot. I'll call it staging. And it takes a minute to set up these slots. While it's doing that, I'll go back to our code. And I just have a simple MVC application. I have a background color. We're going to change that to green. And we'll change the text to green. Comment this out. This is for later. We'll save it, and we'll publish it out. So if you've ever seen an Azure published before, you've seen, when you're logged in, you have the options to publish out to an app service. Once we've added these deployment slots, we'll have some additional options down here. So we now have the one staging that we just added. And we'll click Finish. And all right, now it's doing its publish thing. So 1 second here. Of course, it's going to take forever. All right, so let's come back here. We got our blue site. When we're ready, let's check on it. Just about done here. I should have pulled Bootstrap out of here. And jQuery, I think it has. All right, that succeeded. So now our code's all out here. Let's take a look at what we got. So like I said, you have a new URL for it. And so there's a new URL for it. So if you need a staging site, this is a fantastic way to do it. It doesn't cost you any money. And when you're ready, you can hit this swap button. Of course, most of the time this is going to be done through CI/CD platforms, but I wanted to show you how it's all done normally, or without that. We're going to choose our staging slot, and these are, it'll preview the changes that it's going to make to the configuration. Now I'm capable of doing PHP 5.6, which is terrible. And we're going to hit deploy, and then we can come back to our site. Come on. And I'll just keep refreshing, and eventually we should see it change here. The swap does take a minute because it has to go through all those changes I talked about, the configuration changes, and there we go. Look at that, instantaneous deployment. Now, there are some catches to that. The warm-up that I talked about, that's a very simple site, so it doesn't really take any time to warm up. But a more complicated site would take a little time. So what I've done is I introduced sleep out in a site I've already published. So when this site warms up, it's going to sleep for 30 seconds. So we'll simulate a little bit of a delay that you'd see in an actual production site. And we'll close this one. So now we're going to do a swap out from our staging without warm up. I just want to check one thing here. go ahead and do it. So if we swap this one, and I did everything right, we should see a little bit of delay here. Come on. There we go. So the service is unavailable because it's warming up, and then eventually it deployed. I was expecting that to flop to blue, but I must have got my colors wrong when I deployed it. All right, so how do we fix that little bit of delay? We use a health check. So I have another site where we can add in this health check option, and we're going to register in a class and then make a route for it. So now we have, it inherits from or implements this health check function. So let's go to there. Take a look at it. Same thing I showed you in a slide where we're inheriting from iHealthCheck, and we're implementing this method, check health async, and we're going to, it has a website, well, a page that will display healthy or not. So if we look out here, and since I messed up my colors, we're going to have to redeploy here. Just take 1 second. All right, so we got our, and we're going to go blue. Otherwise, you would not be able to see anything. While it's doing that, we're going to go and look at the configuration settings we've got to make in Azure. So under the slot in the main site, we're going to need to add in this property, the website swap ping path, and this has a value that points to our health site, and it also needs to be on the actual app service, our production one. Come on. Add it in here. And when we save a setting, it does reset our website, so we'll go ahead and start it up. I knew something was wrong. It did change to blue, so I'm going to go ahead and spare you. Oh no, I want to change it to green. push this out. Let's double check here. So we're in blue, and I'm going to publish it out to I swear it's worth the wait. Cancel. Let's shoot it got to production. And of course I've crashed Visual Studio. So we're just going to go ahead and do it, and the site won't actually change. Man, I have crashed everything. Okay. So with our warm-ups in place, we're going to perform the swap. And we should be able to click through here, and it's going to deploy our new site, blue on top of blue, without any sort of warm-up. We'll just have to trust that it's working. So by now it's probably actually deployed the code. So let's go back and talk about something else. So a couple of gotchas with it. I mentioned that when we do this deploy, it's going to be in a cold state, and we'll try to avoid that. Another gotcha is that the environmental settings will be applied from the environment that you use your slot in. So when you release in a staging environment, and let's say you grab an environmental variable of the host name, and you use it in a singleton, it's actually going to continue using that environmental variable from staging throughout the entire spot. Another gotcha that I've had is that when you do this warm-up, it can't use HTTPS. You have to carve out a route to make it so that it can use HTTP. That's just kind of a setting in Azure, and there's no way around it. So just a gotcha. Another important thing to talk about when we talk about deployment is how we're going to deploy our database. With the database, you have lots of opportunities for problems. When stuff goes out, you don't want to upgrade stuff in place. Otherwise, your users are going to be down. You might as well take the website down. Well, you probably have to take the website down. So for database deployments, we follow this create and destroy model, where we create new tables and queries and procedures. We don't modify stuff right away. We just create new ones, and we come back after they're being used and destroy them. It could be a couple days, or it could be a week or so. There's really no problem once you've created it and have your code out there to run on old stuff, but you do want to clean them up and destroy them for just to be a good tenant of your database. So the other type of deployment that I'm going to talk about is Canary. So this comes from the old mining tactic, where miners would take canaries into the coal mine to figure out if the air was safe. If the canary died, they knew they should get out. Don't worry, we're not going to kill any canaries in this talk. We're just going to disrupt some users. So in this kind of deployment, the code is partially released to production. The code changes are monitored. When everything looks good, it's fully applied. There's no sense of time during this. You could leave your code out a day and do all the user testing on it, and then you would deploy it. So I guess the main problem though is that some users, if you don't have your code right, some users might get the problem. But it's good because they get it, so the vast majority won't get it. A good use case for this is if you have to frequently revert a build, or if you have some hard and complex changes that are impossible to test manually, maybe race conditions or stuff like that. So from a topology, this Canary deploy would look like this. It's traditionally done with multiple servers. You would deploy the code out to one server and test it, let your users use it, get your learnings from it, and then deploy it out to all the rest of the servers. So you can use the deployment slots for Canary deploys too. We'll slowly increase the traffic flow. We'll move it, from 10% to 20% and keep on increasing. And while it's out deployed, you can append a parameter to your query string, and you will get the new site if that's what you want to look at. So let's take a look at what that looks like in Azure. So we got our normal production site. For some reason it's slow. Or down. All right, we're going to deploy something out here. I knew I probably should have avoided live demos, but I really wanted everyone to see how to do it, because I've been to talks where we talk about the deploying frequently, but I've never seen anyone actually do it, and there's probably a good reason for that. So we're going to deploy the site out again. Let's take a look at this. So over here on the left, in our deployment slots, we have a percentage of traffic. So we can use this to deploy our site partially out to production. I also have a site over here called Canary. I just put a picture of a canary on there. Let's see here. So we got our production site and our Canary site. I'm going to go through and put about 20% of our traffic over to the Canary slot and hit save. We'll see here. So now it's done its work, and we come back to our site. We're still getting green. I thought this might be cool since we have a bunch of people in the audience. Let's see if we can't scan this real quick and see who gets a canary. If you got a second. I got green on both sides. Did anyone get a canary? Hey, someone's got a canary right there. So it does actually, did actually work. So then eventually, once that person has looked at our canary and we see that from our logs that everything looks good, we're going to go ahead and complete the swap. So we're going to choose to come from our canary. And the reason you have to actually complete the swap is even if you move the traffic up to 100%, now everything's running from the staging slot, and you're not running with all the the settings that you would have on your production slot, be it, the load balancer or the different instances. So this is going to complete here. It might have already completed. And now we have our rather large canary. So that's what a canary deployment looks like. It's not a whole lot different than a blue-green deployment. You're still using a proxy, and you've changed around where the users are going on the fly. You can do that at any time during, I probably wouldn't do it at peak demand, but you can probably find a time that's not 6 a.m. to do your deployment. I got some backup videos just in case. So now we move on to software versioning. Another key way that we can get our code out faster is by using versioning. We've been versioning for a lot of years. This is how traditional software is maintained. We have a major version, a minor version, and patches. If someone puts out a major version, that means that they are going to break something, and you should take care when you pull in that new package. And the good thing about when we version software is we can release as fast as we want to. So if I can release 12 times a day, and it really doesn't matter because I just put out a new package and it's got a new version, and if someone wants to use the new version, they can. If not, they will just stay with the current version. This is still widely used for NuGet packages and NPM packages. API versioning is a little different. We want to be able to evolve our product with little to no impact on the customer. You could have thousands of clients that are out using your site, and we don't want to break them just because we decided to change up our contract for everything. The other thing that makes them a little different is the consumers are using our hardware to consume the application. And that means that we can't just deploy something new out and we will mess them up. So we got to use some sort of proxy-based deployment strategy. Typically, you could just handle pushing out a new version through the blue-green that we've already talked about, or a canary. But you get into a situation where your software needs to evolve and you don't want to break your existing customers. So the way this works is the consuming application is given a new URL or a new parameter, and you process this and display what you want to them so that you don't break them. API management solutions will help you control which version is being referenced. So there's a couple, in addition to transmitting our version, we also need to worry about how we're storing our code, and not only how it's stored, but how it's actually used. So we got a couple different methods that we can use to version. We can keep everything in a simple code base. So we would, in a web API, we would make like a new route, and then we just add a V2 in our path, and we could use new objects for the contract. Everything's kept in the same code base. It's pretty easy to use. This is probably the most common way. There's a couple libraries you can use that'll help you out with this. There's some other ways we can version it too. If we're doing a big, huge refactor, we don't even have to keep the same code base. We could copy everything out to a different branch and just release it to a different spot. There's another way that the Microsoft flow in Git, where we cut a branch as soon as we do a release, and you would publish out that branch to another site. And then if you updated the main and it had changes that needed to go into that branch, you can cherry pick them out to that branch. But we're still going to have new hosting for each time we make a branch, which in the cloud is not a huge deal because we'll just spin up more. Someone will pay for it. API management is a solution that we can use to route our traffic around. It is basically our proxy. It has a couple of additional features that are good for continuous deployment. We can keep a catalog of all the APIs that we have. We can keep versions. Older versions can be monitored and deprecated. If someone's using something that's old, you can, notify them that, hey, I'm going to get rid of this in a week or two, and then cut them off if they don't move off. And you can also keep a change log for everything. It's just kind of a static site, which helps inform them of the changes going on in your code. Inside of API management, there's two concepts that you need to think about. You have revisions. These are for minor changes, changes in implementation. Additional functions could also be that. And then you have your versions, which are for major changes. These could be changes to breaking your schema or changes to how something is returned that might break the consuming application. You also have a couple of different ways that you can transmit your version number. So we can transmit it via a URL prefix, a host header, a query string. The URL prefix is where you put like a v2 in front of your path. Host header is transmitted in the host header. Better to explain that. The query string is at the end of your query or end of your URL. So revisions are handled internally. You can get to them, but they're not really meant to be published out to other people. It's more so you can test your code and take care of any sort of problems before they get to your user. Another consideration that you want to think about if you're having problems with deploying your APIs is that you probably want to split something up. So you can, if you're having, you can deploy if you have a big monolith and every time you deploy it, you have some sort of problem, this little function over here causes a problem, but I don't need to revert it because I've split it up into little smaller spots. So ideally, you're going to want to split your application into whatever it affects. So if it's an API that deals with products, you probably don't want to combine your products and your sales and your distribution all into one package. You want to have them in smaller packages. That way teams can move independently, deploy out whatever they need to, whenever they need to, and that way you can achieve a high velocity for your API. So let's take a look at what API management looks like. Here's API management in Azure. We have APIs, and I've gone ahead and added one in, call it weather. I just used a standard, we'll take a look at it. I used a standard, just the starter API. So for the first one, it's going to give us a weather forecast that's 5 days long. And I made a second one that I hosted someplace else. And it gives us a 10-day weather forecast. And if we come in here, we can run it internally. And we we see that we get back that 5-day weather forecast. If we run it through Postman, we're actually calling a different URL. If we look here, we're deploying at StirTrek API management, but the external facing URL is different. It's on the API management. The other key portion is that you have to pass in a subscription key, and this tells Azure who's using it. That way you can deprecate to them or deliver certain features to them, control their experience. We run it over here. We're still going to get our 5-day forecast. Now we're going to make a revision. So we'll call this revision 10-day forecast. And we'll make a change to how the backend URL that it's using. We're going to point it at our new site. Hit save, and then when we go to test it, we're going to include this revision 2 in the URL. And if everything works good, we now have a 10-day forecast out. But if we look at our users, they are still getting the 5-day forecast. And we come in here to revisions and make this one current. And hopefully we should have a 10-day forecast. That might not, we might have caused some problems with that. So obviously we didn't in this one, but let's go ahead and roll back to the previous version. Now we can take this version and make a version of it. We're going to say v2, and this is where we get to choose, not v-at, this is where we get to choose how we're going to version it, where we're going to transmit it. I'm going to choose the path. We could also use the header query string, and we got to give it a name. So now we have a separate API under the v2. For some reason, it never transfers over the actual back end. So I'm going to change that real quick. If I've done everything right, our original API should be 5 days, and we'll have a new one, v2, and it has 10 days. So there we go. That's my quick demo of API management. It's got lots of other features in there, but we only have a limited amount of time. So sum it all up, the reason I got you in here was to talk about how you can get more sleep with doing these continuous deployments, but the real motivation for it is to have you deploy your code quicker and get the learnings quicker, get more value out to the business faster. And we talked about the blue-green deployment, where we swapped slots and had a proxy point between our two different code bases. We talked about the Canary deployment, where we partially released everything out to the public. And we talked about API versioning, where you can control your API, what your user sees, while maintaining it differently behind the scenes. You can contact me on LinkedIn. I do have these slides available on GitHub. I'd like to say thank you. I'm with Insight. It's a fun company. We have lots of creative people. We do some awesome things. We're big in chatbots, IoT, cloud, infrastructure as code, mobile applications. It's a fun place to work. We have foosball tables, ping pong tables. We have a whiskey tasting on Wednesday, and we do lunches and all kinds of stuff. Great place to work. I'd love to talk to you if you want to come over to the Insight booth. Does anyone have any questions for me?
There actually were 3 questions in the Slack channel, so
okay, we had
I'm not repeating them after I tell them to you.
Yep.
So the first one, do the Canary builds include sticky sessions? For a more complex site, could they load the main slide?
Let me get the first one first.
Okay, sure.
All right, so the first question was, do the Canary builds have a sticky session? Yes, they are extremely sticky. So when you go to, if you get the Canary experience, you're going to continue getting the Canary experience. The only way to switch out of it is to use the parameters for the query string, and I've even seen times where I've had a hard time switching out of it. So what's the second question?
So this was just kind of a follow-up to that. So for a more complex site, could they load the main slot for the initial page, but then get a Canary on a call to retrieve data?
Okay, so the question was, for a complex site, could they load the main site on a standard page and then call a function that would be on the Canary? So that comes into how you have your application structured. If you were to structure it as that separate site as a microservice, then you could choose how to deploy it however you wanted to. So you can, that one function, you break it out using API management or something, and then you can choose to do a Canary on just that portion. What else?
Next question, is it possible to use a Canary deployment for one release and then the next release use a blue-green deployment?
The question was, is it possible to do a Canary deployment for one release and a blue-green for another? And that's definitely possible. You're kind of independent. The Canary can kind of be a separate step if you have some complexity to your code. You increase the percentage that's going to that slot, and then the next time, if you don't want to do the Canary, you can just hit the swap button and everything will go out how you want it. One more?
Yep, one more. What's been your experience with the Azure API management in terms of pricing?
Azure API management is a little pricey. It depends. I mean, I'm not paying the bill, so I don't really have much experience on that. But it is a pricier service. I think you get what you pay for. It's extremely nice to be able to control how your API is done without doing it, on a front end sort of manner. You can control everything about it, and you can even, include subscriptions. And if you have a problem with the price, maybe you should charge a subscription for what you're selling. So, is that it?
That was it, yep.
All right. Well, I'd like to thank everybody. Have a great time at StirTrack. It's great to see everybody in person, and I'll be at the Insight booth if you have any questions for me. It's been my pleasure to talk to you today.